What's up, everybody? Axe Wizard here, back with a pretty big update for my game. I've been busy for like a week or two on this current project of getting a star map working, and I've got it working. So let me show you how it works in the game. So, right now, nothing. I also added a option to steer with the mouse, which is what this is, because I found it was a lot easier to target ships if you did that. So that's an option that you can toggle on or off, or you can just use your standard WASD, but the A and D don't really work that well when you have mouse turned on. So I did that. You might notice that over here, if I'm not in the way, it says selected system NA not applicable. So if I hit M for map, boom, it brings up a map and it pauses the game. So you don't have to worry about what's going on. Now, this obviously isn't the final map. There's still lots of things I have to do with this, but I can zoom in and out, and you can see. So currently, this is where we are now. This is the current star system. I'm just going to call it Genesis. I don't know. It seems like a cool thing. And the only other neighbor system that we have right now is Harmony's Reach. So if I click that, that is now a selected star system. So if I try to warp now, like we're too close to the system, so it plays like this sound for now. I need to have some sort of like notification on the screen or something like that pops up for it. But what we can do is if we'll just boost over here. I still have to add a cooldown on boost so you can't abuse it, because right now you can just keep like boosting and you just go super fast. So your speed stays up there the whole way. But anyway, so if I were to hit the warp button, which I just have set to N for right now because I don't know what to put it at. Here we go. And here we are. We are now at another system. And look at that. Perfect. So what's cool is, like, if I go and follow this guy over here, you're gonna see him actually like warp out of here. So ships no longer just disappear when they're going. I also made it so that other ships can warp too. So he's slowing down. So he's gonna face this way over here, and boom, he's gone. So now we have ships actually you know, getting out of here, which is super cool. So now that I've got this all working, there's a few things I have to finish up with my star system mapper tool. So we went over that last episode. I made this external tool where I can plot out my star system. So currently I only have 2 star systems. I have the one you started and then another one. I didn't want to do a bunch right now because I hadn't even got it working yet. So now that I've got it working, there's a few things I need to actually handle, add to the star system mapper tool. I need to add in, there's a few things. I need to be able to determine like what background to use. So if you look at the stars background here, this isn't going to be the same background for every star system. It could be different. It could be like a super, you know, like bright and colorful crazy star system. It could be, you know, just a bleak, boring star system like this is now. It could be like have a bunch of cool, like I don't know, just stuff. So different backgrounds. So I need to be able to determine that, and that would be stored by location, and or not location, star system. There are multiple locations inside of a star system. So I need to be able to handle that, and I also need to be able to determine like what ships need to spawn in that system. So for example, I can set the faction of a system currently, and I could probably do a little bit of stuff with that, but you know, if I'm pulling up to Earth like Genesis, the main system, I expect that to be a very populated system. But if I pull up to some, you know, border outpost of some faction, it probably shouldn't be spawning like 50 ships, and it probably shouldn't be spawning a bunch of capital ships. It should, if anything, have like a bunch of like maybe domestic freighters and, you know, maybe like a fighter or two or something like that just hanging out there that's stationed there. So I need to have some way to determine that. And I'm just not quite sure how I want to do that yet, but I do know that that data should be stored in the star system. So I'll have to figure out a way to make that happen. That fighter that's going up there, he's probably going to boost like down here in a second. I'll be willing to bet we see him fly by. Yeah, he's turning, and he should fly by any second. There he goes. Come on. Woo! There he goes. Good job, little buddy. So yeah, so it's working. Still got some room for improvement. So for example, the map, it's not much right now. So for the map, I don't know if I want to have it be like a smaller window so you can still kind of see like what's going on around you, or if it's semi-transparent, like some overlay like in Diablo 2 or something for the map. And obviously right now these are just super generic. Like I have a circle that I drew that I colored white so that I could color it as I want. I got a basic line 2D that's connecting it, and that's it. The background is just a blank because I had to add a viewport, and I spent a lot of time fighting with that, so that's going to be fun when we do our little code review here coming up. But yeah, so there's going to be a lot more systems. I still have to test like whether or not, you know, my code works for displaying a system that you haven't discovered yet, and it doesn't have any neighbor systems that you've discovered yet, like they shouldn't be visible. So I'll work on that as I add more systems. Like I might add like 1 or 2 more systems just for testing, but I need to focus on rounding out what data I need from the star systems. So I need to be able to have, you know, what background to use for the star system. I also need to be able to determine a system for determining what ships should be spawning. So I think what I might do is, I think for that, I can probably rig up something that has like different, what's the word for it? Like different stat weights. So for example, like if I want more, you know, cargo ships to spawn, I can give them a higher weight so they have a more chance to spawn. I can also store some sort of like spawn rate. So, you know, maybe instead of spawning a ship every 2 seconds, you're spawning a ship every 20 seconds, you know? So I can change that around. Also have some sort of maybe like variation of it, so maybe like 15 to 25 seconds rather than just 20 seconds, so you can specify like that variation range. I might have to store that as well. And so obviously a path to the background to use, which before I can do that, I still have to fix how I'm handling my parallax background, because yeah, so there's lots to do, but I got it working. I'm super happy. It took a long time to make this happen. So if I can escape from this, actually no, I'm gonna hit there we go, hit Earth, and then let's just go ahead and I'm gonna keep boosting out of here like a cheater. Oh yeah, I already selected, never mind. And then we're gonna boost on out of here and go back to Earth. Go back to Genesis. Look at that, and we're back. So that's super cool. Oh, whoa, I didn't mean to go that fast. Okay, stop, slow down, slow down. So yeah, now we're back here, and I had to refactor a lot of stuff to make this work, because there was so much code that I just slapped together, and it was a lot of tweaking to make it work. So that's what I got to show you. Let me just double check to make sure that that's all I've done. All right, so let's do our code review portion here. I'm wondering if it might be kind of, actually before we do anything, let me save this stuff to, let me push this up to GitHub, because I do not want to lose this stuff here. So let me just open a git bash here. There we go. Git status. You're going to see a whole lot of changes here. A whole lot of changes. Yeah, look at all these changes. So these are all the changes that I've made. And then these are all the new files that I've added. So not necessarily new files. Some of them I renamed. So it says here, like, for example, I deleted like SPR Moon and SPR Earth. But in reality, I actually just moved them to like hand-drawn locations. So I moved stuff around. But yeah, lots of changes. So if I just do a git add with a period, it's going to add everything. We run another git status. There we go. So now we can see that, yeah, see, now it shows properly renamed or new file. So lots of stuff that I've done there. Let me resize this. Oh, I guess it only goes so big. That's fine. But yeah, lots of stuff. So if I were to just git commit, oh my god, star systems are working, lol, right? I'm the only developer on this project, so this is obviously not a super professional commit message, but I don't care, man. I'm so happy this works. So I will commit all that, and then I'll do a git push, not capitals, git push origin main. And it should push everything up to GitHub. There we go. So now that's up to GitHub. So now, if I go back to my game here and refresh this, woo, look at that. Now we can see that star systems are now working. So if we wanted to do like a code review on here to see what changed, we could. But I think this would be a lot kind of more boring. And I'd rather show you in context of stuff, but this is also a view that you can use to do an actual code review of, you know, what your changes are. But let's just jump into what I've done, because I've kept like a little change log here of what I did. So let's just go through the list here. So I added the star system map tool. We went over that last episode. I wanted to do both. I wanted to have, hey, I made this cool tool and this is what it was for, and bam, it was dope. But it was too big, so I just did a star system mapper tool. I did its own episode, so we don't have to talk about that. I added the option to steer the ship with mouse, so let's talk about that. So that small change. If we go to, I got a function here called rotate ship, and what I did was I found that I was repeating this same code to determine, like, you know, where we need to actually turn. So for example, AI, whenever they want to go somewhere, they have to determine which way they need to rotate their ship. And I was calling that in a bunch of places, and I also wanted to call it for my player if using the mouse position. So I made it a function, and I haven't gone through and actually implemented this function into the AI functions yet. So I still have to do that. That's going to come when I do a much needed code cleanup on this file, because if you look, my ship file is like 1,300 lines of code, which is quite a bit. So if we go back to this rotate ship, it's using the same logic that we did before, except the only difference is now it has the ability to take in a target position, which is what it was using before. And I have this set as a optional variable, so I'm specifying a value for it here. So just a 0 value vector2. So if someone wants to like omit it, they can. And I also specified angle as an optional one, so I'm setting it to be 0, which is a float. So I just added, hey, are we using float or are we using our angle? Actually, no, we're prioritizing target position over angle. So if you supply both, it's only going to use target position. So the target position is doing the same calculation it was doing before, where we're using a get angle 2, and we're converting that to degrees for a calculation. I think I can probably factor that out now, but I don't know, because I'm kind of like converting it here, so radians to degrees, and then I'm also converting it here degrees to radians. So I keep like flip-flopping back and forth when I could probably realistically just make it work with just radians and wouldn't need to do that conversion at all. But we're going to get to that. So this is the code it was doing before. And then I added the option to use a supplied angle. Now this, I have a code comment here. It says, note, this does some fancy things that I'm not sure what it does. And I put a link here of the documentation. I think I still have that up. If you want to, because what was happening is in Godot, I was using a position, so a vector 2. So this get angle 2 was using my position and then getting the angle to the target position. But if I'm just trying to get the, the angle to the angle difference to my angle, I wasn't able to use get angle 2. And there wasn't like a equivalent I found. So I Googled it and I tried to ask ChatGPT. It gave me a bunch of wrong answers. It's not really proficient with Godot a lot, but there's it helps. It usually gets me on the right path, or at least gives me more things to Google to figure stuff out. But I found this. So this guy basically gave us a little function that he did where he uses this FPOS mod function that's like built into the system, and you're subtracting the angle you want to go to from the angle you want to go from. You're taking your from minus 2, or your 2 minus from. You're adding pi, and then you're doing pi times 2, which I believe Godot uses tau, or TAU, which is basically pi doubled. And then you're subtracting pi after it. So I don't understand exactly how or why this works. It has to do with how radians are used, and I never really looked at that much, but I copied and pasted it. I modified it. I also stepified it. That way I could make sure that it is a comparable value, because with floats, sometimes you'll get like, 0.00000001 or something like that, and it won't quite be 0. And so if you're trying to compare those, that's a problem. So I stepify it to make sure it's only like 2 decimal points, and it seems to handle that pretty well. So here I'm just doing a similar thing where I'm doing my FPOS mod angle minus rotation. So the angle is where I want to go to. The rotation is where I'm currently at. That's where I'm coming from. I'm adding pi. The second argument in the FPS mod is this TAW or TAU, which is pi doubled. And then we're subtracting pi just like it was in there. And then I'm stepifying it. And I'm also converting it from radians to degrees, because that's what my calculation was using before. So I just threw that in there and it works. I'm not sure why it works, but it does. So I put a link if I want to go and research that later. But as of right now, I'm just glad it works so I can move on to getting other stuff working. At least that was my mindset when I got it to work. So yeah, I use this rotate ship function. And then if we go up here to get player input, this is where the all the player input comes from. It's just just checking, hey, are we supposed to be accelerating, blah blah blah. If not, so it's just checking all these actions I have set in my input map and my project settings, and handling stuff. So here we have a let's see, where is it? Did I put it up at the top? No, I didn't put it here. I put it in my process event. Yeah, so I added this little thing here. I have a to-do so that when I implement game options, like you can actually hit like escape and bring up a menu and go to options and change like some game options to customize how the game plays for you. When I eventually implement that, there's going to be a toggle that you can do to steer with mouse options. So if you have it checked, this will fire. If you don't, then you'll use A and D to rotate your ship, which is how I had it previously before I implemented this. So I'm just saying, hey, if we are the player and if our state does not equal state hyperspace, I'm going to get into that portion in a little bit, then we're going to rotate our ship. So that's how I got that rigged up right now. Again, that was something I just threw in there. I have a to-do to make that more polished, especially once I get options working, which is something I have slated for later on down the road, when I get a lot more of the core systems working, then I can start actually bringing up an options menu and all that stuff. And so there, first item done. Cool. So bam, I can knock that out. I added a visual indicator for hostile ships. I guess I can show that. I don't think I showed that last time. It's just my little selected indicator, except if I... Here, come here, dude. There you go. So if I leave him alone, you can see he's got this red indicator on him now. So it shows that he's hostile. And I found that was a lot better, especially if I go back into the game here and I re-enable factions being as enemies. Boom. I turn those off so that way I could show off how ships go to other systems. So now you can see, like, I didn't attack that guy off the bat. He just he was an enemy, so he's now designated as an enemy. So that guy is also an enemy. So I know to run as opposed to having to constantly look at my mini-map and try to see the different colors. I still have to fix this bug where the fighters aren't considered enemies until they actually shoot me. But I'm still working on stuff. But yeah, so I added that. So let me go comment these back out because I still want to do more testing. There you go. Save that. Let's go back to main. So that's all I did. It's just my same indicator, except I'm adding it to enemy ships and I'm coloring it red. That's all I'm doing. So, bam, knock that out. Woohoo! I guess I could show where I'm doing that. Let's see. It might be under add ship to enemies. Yeah. So here I'm saying, hey, are we the so this is the function that whenever somebody wants to add me to their enemy list, like my ship that I'm controlling or whatever ship this is, it just adds a ship to our array of enemies. So just validating if the ship is valid, if you know, if we're already in that list, we don't have to do anything. If we are not tracking this as an enemy yet, add them as an enemy. And if we are the player, then we are going to execute this code down here. So I am loading this indicator scene, which is I think what I had before, which is just right here. So again, it's just a sprite, and I just have some code here to make it rotate. I have some code to make it scale to, you know, what it needs to be, and I also have it rotating. So that's the little scene I've got there. And I went back to ship here. So I'm loading that, and I'm instancing it, and then I'm modulating the color and scaling it using its own scale to sprite function, which I made, and then I'm adding it to the ship that's an enemy. So that's how I'm handling that. So that was a cool little change I did there. Pretty simple, but it works. So big thing I did is star systems. So holy balls, this was a lot harder than I thought it was going to be. So first things first is I had to refactor how I handled locations, and also had to do some thinking on how I wanted to load in star systems. So let's talk about our locations first. So previous to this, how I was envisioning I was going to handle locations was I was going to have a locations class, which I still do, a location class. And that class was going to do this did a lot of things previously. So if we were to like go on GitHub, yeah, here we go. Browse the repository at this point in history. So before my last commit, if we go look at our classes and we go look at our location, you can see there's a bit more here. So this was, I was treating the location class like it was just going to be a kind of like my ship, how I would instance it, I would set a bunch of these export variables, and then I would just create a scene for every location that I wanted. And once I came to the realization that, you know what, I'm going to have potentially, you know, hundreds, even thousands of star systems that each might have like 1 to 5 locations or something in each of those. I could have thousands of locations. I don't want to make thousands of scenes. I just want to make one location that I can, you know, set some common things on, and then it's all handled. So I started thinking, okay, well, what commonalities like are there between all these locations? Or what differences do I need to keep track of? And really, the only differences are the sprite that's being used and the collision mask, so that you can mouse over it or check if you're going to land on it. Those two things were the only thing that needed to be different for each location to be put onto the map or put onto the scene when you're in that system. So if I were to run my game and we run it, this is now running the same location class. It's just that we're setting the things. So we're setting what the what sprite it uses, and we're also setting what the collision mask is for it, so we can determine if we can, you know, click on it or if we can land on it. So those are the two differences there, and then everything else I can just have in a big ass dictionary and populate those things as needed. So now if we go look at our location now, the only thing that we're storing here is the location name. And then on our ready function, we're loading the texture that we stored in our locations, which I'll show you in a second. And we're setting that texture. We're you know, we're getting the size of it. We're setting our collision masks to equal that. And yeah, so that's what we're doing. I have a little profit comment here. So yeah, it looks a lot different than what I did before. So this is a whole different approach. And I was using this pattern to where I would kind of like, I would have a location data dictionary that I would initialize at nothing. And then whenever I needed to pass this data on, I was consolidating it here from all these variables that I would set from defining my scenes. But since I don't need to define thousands of scenes, I can define one. Everything is now in this locations. So if you look here, this is my master list of every location in the game. So currently I've only got 3. So we're storing name, which, you know, the name is the same as the key. But if we have to pass this information anywhere, the name might not be accessible just by the key alone. So I'm including it in there just like I did with Star Systems earlier. We have the description of it. We have the position that it's going to be in the system. And we also have the path to use for the sprite, the path to use for the background when you land at it, when it displays the location window. And then we have options for the menu buttons. So, you know, you can see we're setting them to be true to show, and we're determining what the text is. So you can see here I changed bar to like work postings because I don't know if I want to use bar or not, but that's what it's referred to as right now. And we're not going to show anything special about we're not going to show the special button because you can't do anything with it yet. But if you did, it would probably be Syntocracy HQ, but we can change it around later. So I'm setting those variables, those values here. So this dictionary is just basically a big ass JSON file of all my locations. Now I have a template here so I can copy and paste and just add more, and that's working pretty well. And as I play with more locations, if I need to add more data, I can add it to my template, and then I'll have to go through every location I've done and make sure that it's added there. So that's why I don't have a lot of stuff done right now. I just want to get 2 to 5 things done, so that way I can have a proof of concept that the systems work, and then figure out all the data that I need for them. And then I can start populating this stuff. That way I don't, I don't add, thousands of locations and then realize, oh, to make this new feature work, I need to add this thing, which I'm going to have to go through thousands of locations and add this in. That's not going to be fun. That's something I'm probably going to end up doing later on at some point, because as we get farther on in development, there's probably going to be some new snazzy feature that I want that I didn't think of, that I didn't account for when I designed this, and I'll have to go back and add it. So whatever, that's just game development for you, baby. So there we go. I've got locations. I'm doing that here within Game Maker. Now, you'll notice I have this in a section called auto loads, because what I did is in my project, under auto load, I have a few auto loads. So I have Audio Manager, which I did like many episodes ago now. I set locations as an auto load, which means it's a global variable basically. So I can access this file from anywhere by referencing locations. And you'll also see that I have star systems set as an auto load as well. Now, it's typically bad practice to just have a bunch of things as global variables, but for this, I think this is fine, because what ends up happening is that I need various nodes all throughout my tree to access this data. And it's such a pain having to like pass in data down. Like if you've ever worked in like React, it's kind of like passing props down to all your components, because your components only have access to what's within scope. So it can't access anything above it, kind of like how a Godot does. You can't really, it's kind of hard to access stuff higher up in the tree. So what I did is I made these auto loads so I can just access them from anywhere, because all these nodes need to interact with this stuff. So my ship needs to interact with my star system and locations. My main does. My AI ships do. Locations need to interact with this stuff. So there's a whole bunch of interwoven things, and this allows everything to access it. Now, I don't want to lean too heavy on it if I don't have to. So if something doesn't need to be accessed by many different things, and I can't find a good way to streamline that, like if I can't just make it work smoothly with like signals, which is what Godot wants you to use, then I'll throw it in auto loads. But for these two cases here, it was just so much easier just to throw them as auto loads, as globals that are accessed from anywhere. And that's what I did. So let's look at the star systems. So if we pop open this file, this a lot of stuff happens here. So we are declaring our map. So if we ever want to access our star system map, we're doing starsystems.map. And what we're doing here is we also have a few variables. So we have the variable to keep track of what the current system is. So Genesis is our starting system. Whenever the player selects a new system that is, within the neighbor, it's a neighbor system of the current system, it'll update the selected system variable, and that's what determines where we're going to go when we hyperspace. And then we're getting the path of the file that we need to load and populate the map. So here, I create a folder called data files, which if we pop this open in File Manager, you can see it's got that star system map.txt that I generated from my star system mapper tool. So I'm just copying and pasting that in manually. I might make some sort of like bash script to just copy and paste it for me like safely and automatically, but that's how I've got it working right now. I just manually copy that over. So whenever I want to go into my star system mapper tool, and let's go ahead and double click this, and if I want to run my tool, file does not exist. I must have copied it. Darn it. Okay. So here's what I'm going to do. I'm going to copy this. And then what I'm going to do is I'm going to go into Star System Mapper Tool. I'm going to paste this in here. There we go. I think I just clicked and dragged it last time, which is a cut operation in Windows if you're on the same like drive. So that's what did that. So now let's run this now. There you go. So now you can see it's got the same data that we have here. So now if I want to go in and add more locations, I can do that. And when I'm done, I can just take that txt file and just copy it over to my other project, and it will load in, and then bam, I've got more star systems. So that's how that works currently. I went over the star system tool last episode, so I won't spend any more time on it. But it's loading that file. So let's go through the ready function here. So again, setup, we need a file so that we can use the file functions. So we're declaring a new file node. And then what we're doing here is we're saying, hey, does our desired file actually exist? Now, if the file doesn't exist, then I'm gonna output something to the log here that says, hey, unable to read file, your game's not gonna work. If it does, we're gonna try to open it. If there's a problem opening it, I'm gonna output something to the console. It says, hey, nah, not good. If I really should, now that I've got this working, I probably should put some sort of panic thing in here to where it just closes the game if it fails. So I might do that. I might do git tree, and I think it's what, exit, close game, end game. I don't remember how to close the game. I guess I can go look at my. Let's go look at my UI and title screen. Emit signal. Oh, it's just get tree quit. Okay. So let's go back to where it was. Star systems. So get tree quit. That way the game won't proceed. I'm going to add like a to-do here. Should this panic crash the game? Or should we... Yeah, that's fine. So I'll put that there. The return's kind of redundant now, but, you know, we've got it there. And what I'll do is... I didn't run into that, but... So I'll output something to the console, and then I'll just stop it. Because if I'm not able to load the file for whatever reason, the game's not going to run. In fact, it will just crash if I try to proceed anyway. So this is fine. So we've got that. Now, if the file exists and we are able to open it, then what we're doing is we're using a file.get variable. And this true, if we can look at this, it says, where was it? Come on, don't go. Here we go. So get var, it says allow objects. We want this to be true. So that's what we're doing there. So star systems, bam. So get var, allow objects true. And then once we're done with the file, we close it. And then for now, I'm setting Genesis to be discovered manually here, because if you don't have it discovered and you go to open your map, there's no nodes because you don't have anything discovered, so it doesn't show you anything. So I figure at the very least, the starting system you're in needs to be discovered. So I'm setting that here. I have a to-do to find a better way to handle this. Maybe that's something I can add in the star system mapper tool. Yeah, so... And then I also added this helper function to like get direction to neighbor system, because when you run the game and you look on the map here, so you see the direction that we're gonna go to reach Harmony's Reach here. So I also want you to go in that direction when you hyperdrive. So if we end here to hyperdrive, you'll see that we're facing in that direction, and we boost out, and then we arrive at this location, and we're going in the direction as though we just actually arrived in this system. So I made that function to make that process easier so that we can track that better. So and all this does is if we specify a neighbor, then we will use that. If we leave neighbor blank, if we omit it, because again, I made this a optional parameter here by setting a default value. And if we don't have a neighbor, then we're gonna pick one from random. So you can see here where, you know, we're getting a random neighbor system of our current system. So that's what this code's doing here. I'm declaring rand index because I wanted it to all be readable. I could have done this in like one big ass line, but it would have looked nasty and it would have been hard to read. So I go for code readability over like performance. It would have probably been better performance because it's one less memory allocation, but this is readable. And to be honest, the game I'm making is not going to be some big ass AAA title anyway. So those little optimizations, I don't necessarily have to be as concerned about, but I still have to be aware of that. So when it comes to the phase where my game is feature complete and I'm getting ready, you know, I'm just adding the polish before I finally release it, I'll go through and I'll try to do some optimizations just to make it run better on even lower hardware systems, just in case someone is, you know, I don't know, playing this bad boy on like Windows XP or something like that. They can probably still run it, maybe. I don't know. I'm not developing it for that compatibility, but if I can make it run on lower end systems, it just, I mean, yeah, there's no downside to making your game run better, other than code readability being sacrificed. So when the game gets feature complete and we get towards that stage, I'll focus on doing those code optimizations. But yeah, I'm not worried about it now. So we're just we're getting that rand index, and then we're just picking a random neighbor system that we got from randomizing 0 to the size of that array. So that's all we're doing there. And now notice I have a little note here that says every system will have at least one neighbor, so I'm not having to do another check to make sure that, hey, do we even have a array of stuff? Because every star system is going to have at least one neighbor, so I never have to worry about that. We're getting the position difference, so I'm just you know, with when you look at vector math that Godot provides you in the help manual, if you want to get the vector to something, you subtract what their position is, or you take their position and then subtract your position from it, and then that will give you the vector that points you towards them. So I'm getting that vector, and then all I'm doing is I'm just getting the angle off of that vector. So again, a vector is an arrow that represents direction and magnitude. All I care about is the direction. In this case, I get that from the angle function. So that's what that's doing there. That's my star system's auto load. So it's loading whatever is in that file. And because I'm saving it from my star system mapper tool as a dictionary, I can load that bad boy in as a dictionary and just run it. So I have a comment here that's also helpful. So I'm documenting what the expected shape of this dictionary should be. So, you know, it should have a name, it should have a position, which is going to be a vector 2. It's going to have some locations, which is going to be an array of strings. So I make sure that this is documented so that I can properly account for that, because since Godot doesn't know, and I can't specify concrete types of what I expect, like I can in a language like Go, this is the best thing that I can do, is at least document what it's supposed to be, and make sure I stick to it. So there you go. That's how I've got the star system stuff loaded. Now, that doesn't seem like that's a lot of code, just star systems and locations. And it's really not. I mean, this is going to be as I start adding more stuff to it, but I had to refactor everything else to use all that stuff, and that was a lot of the time and effort was making all that stuff work. So let's see. I talked about these two items. Let's knock those out. So I refactored tons of code to work with these changes. So I have a note here. Previous pattern of passing entire dictionaries is now removed. It just uses location name. So as we saw back here in GitHub, I was, I had this location data that I would pass around to other stuff that needed it. But now, since I have location data is technically an auto load, which is a global accessible variable now, I can just all I have to do is just pass along the name that I can use to fetch that data from my master list. So that's what I got going on there. So yeah, that was a fun change that touched a lot of different files. Location, class, and scene simplified. I think I already talked about that. We already went through that. Let's see, in main.gd, I replaced a lot of the rough testing code to accommodate these changes. So we're in main right now, so let's go take a look at what we did. So let's see, first things first. All right, so a lot of the code that I had to clean up was the setup space scene. Because I had a to-do to determine how to make this more reusable. For now, it's just for testing. I think I can get rid of that because I think I've actually made it reusable now because that's what I'm using. So what I'm doing here is I'm doing the same stuff I was before. So I'm adding my mouse selector thing. I'm adding my parallax background, which I have a to-do here to change properties based on what system we're in. So I've already got that to-do handled there. Add any locations for the current system. So this is where I was refactored a lot of that test code, because before I was just adding in my separate location scenes and then adding them to the scene. But now I've only got one scene, location.scene. I'm loading that in and I'm instancing it. And then yeah, I'm loading it and instancing it. I should probably actually make this here's a quick optimization that I can do. Rather than running this inside of my for loop, which is iterating through every location a system has, so I could have potentially like 8 locations, and I would have 8 separate load calls to load the same file. What I can do is I can just make a variable here. Ensure we aren't making unnecessary, I don't know how to spell this, unnecessary, that's close enough, whatever, load calls. So I'll do var, and I'll say location scene, and it's going to be a type packed scene. I always like to include my type declarations in here. That way Godot can, the linter in Godot can help find a lot issues a lot easier. So I like using types. It also makes the code a lot more readable, so you can see what you're actually trying to do. I think it's very helpful. I'm glad that they have support for that. I think I'd be kind of nuts if I couldn't specify types. I just love Go too much. Like I work in Go a lot at work. I love that language. It's very powerful, and I like the fact that I can do some Go-like things in Godot. So pack scene is going to equal this. So I'll just copy this bad boy, paste that there. There we go, because we're loading a .tscn, so Godot knows that it's going to be a packed scene. And then what I can do here is I can just do location scene instance. There. So there, I just made one quick optimization. I'm only calling one load call, and I'm just instancing that same pack scene. So that's a quick optimization I made there. Good job, me. Good. This is why we do code reviews. So once I instance my location, I'm setting the location name, which is that key that we use to access data. So you can see here, I'm referencing that locations, which is my auto load. It's this thing here. So locations.list. So you can see here locations.list, and I'm just using the location name. So since our star system could hold multiple locations, the first one's going to be Earth for the star system Genesis, and then Earth's moon. So we're storing that in locations. So you can see it's using this key here, Earth. It's going to fetch all this data. Or use what it needs from this, and then when it gets to Earth's moon, it's going to fetch all of this data and use what it needs from that. So you can see here we're using the position variable value, which is this. I short named it POS or pause because I don't know. I should make it position, or I should make star systems pause. Like I like to have continuity, but Yeah, so you see here, I use position for my dictionary, but in my locations, I use pause. So, I don't know. Not a big deal. I would like things to be consistent, though. So there we go. So I'm getting that information there. Let's go back to main. So I'm getting the position that we need to actually set it. So I'm setting it to be that position. I should probably be global position, but it seems to be working fine. So I'm not worried about it. And let's see. So we're adding it to our locations group, just like we did before. And then now here I'm creating my player. So I'm just I have ship 1 right now. I still have a to-do to go through and, like, you know, not do this. Like, I'm preloading 12 different ships, which is not a good idea. I should only be loading the ships that I need when I need them. But not that big a deal. But that's, again, I have a to-do here. This is just testing code. So I'm going to get to it eventually, okay? Stop bugging me. All right. So we're instancing our player. We are setting our player to be true because on our ship class... Oh, I didn't do a type declaration here. It wants us to be a type ship. Oh, right. Never mind. I'm not declaring that variable here. I declared that up top here. So you can see var player is of type ship. So I already did that. Go me. So yeah, player, which is of type ship, it's going to be ship 1 instance. We're setting our player variable to be true. So that tells the ship class to allow the player to control the ship rather than using my crappy AI code to control the ship. That makes it so I can have reusable ships with just one class, one code base. I'm adding that player to the scene. And then I have this variable called warp angle. And I'll get into that in a few. But that's what lets me determine where I'm going to be placed. So if we have a warp angle, I'll just get into it now. If we have a warp angle, I'm setting my rotation of my ship to be that. So if we're here and our star system that we're going to is up here, I want to face that star system. And then when I get into that star system, I also want to keep facing the same way I was and have that momentum going. So what I'm doing is I'm setting my position to be like in the opposite direction and a certain distance away. So how I'm doing that is I'm normalizing a brand new vector. So I have a vector with a value of 1 and 0, which is going to be facing to the right. And then so if you have something facing to the right, the rotation is 0. So we have a 0 rotation. So I'm using the rotated method, and I am doing the opposite of the warp angle. So since Godot uses radians, if you just add pi to it, which is like, 3.14, whatever it is, then that gives you the opposite direction in radians, which is what Godot uses. So that will change these values for this vector. It will make it, it'll make that arrow rotate to wherever it needs to go. And since I have this normalized at a length of 1, if I scale that by however many units I want it to be, so in this case, like 2000 pixels or whatever it uses, it's going to go in that direction, and it's going to set the magnitude of that vector to be like 2000. So that's how I'm setting that there. I'm also setting my player speed to be the max speed that it can possibly go. Now there is a little bit of a hiccup here. Now sometimes if the scene takes a while to load, this get process delta time can return a bigger value, or if it takes longer to load, then your speed might be faster or slower. I'm not sure which off the top of my head, but it's not like a static speed. So I might have to have a to-do in here to handle that, because there were some cases to where like it just kind of lagged, like especially early on when I was testing it, and it would it seemed like my speed was either slow or I would go stupid fast for some reason. So I gotta iron that out. But let's see. And then after we do that, we're clearing our warp angle. So warp angle is set when my when the player actually, you know, completes his warp. It's I think it's setting that. We're gonna get into that in just a little bit. Otherwise, we're doing what we did before, where we are randomizing the player rotation, and then we're setting the location to be the player last location if we have it set. If not, it's just going to be this. It's just going to be 0, 0 for its location coordinates. And we're doing all that stuff that we did before. I have a signal here that we connect. So I have a hyperspace complete signal that I connect to this warp to new system function. So if we go here to our methods, warp to new system. So what this does is we're setting our warp angle, which we were using before. Again, we're referencing star systems, which is our global auto load. We're using that get direction to neighbor system function, and we're specifying the selected system that we have. Once we've done that, we are setting our current system to equal our selected system because we're done warping, and we're clearing out our selected system. And then from there, we're calling clear scene, which wipes everything, and then we're setting up a brand new scene, and that's where we went through that code earlier. So again, set up scene, gets the data from the current star system, and then it goes through and sets up all the locations from that. So that's how I made that reusable. So I had to refactor quite a few things there to make all that work. But yeah, that's the gist of it. There's a few other things I had to do as well. So for example, like when I was opening up my location UI, I was passing in like location data before. Now I don't have to do that. I just have to pass in what the location name is. And so that was a nice little change. So that's all we did there. All right, so we talked about this item. Let's see, location window and trade screen were also updated to use location name and data from locations.gd. So location window, if we go look at that, that's under UI. UI location window. So if we go look at this code here, before I had this variable called loc name or loc data, which is, again, I was passing in the location data, and then in my ready function, it was specifying all that stuff there. So if we want to see what that looked like before, we can go to, let's see, we are looking at my previous commit UI. Location, am I at location window or trade window? I don't remember. I'm looking at location window. Okay. So if we go to location window.gd, you can see here it was expecting a location data dictionary. And then I was basically setting properties based off of all that location data. So I just tweaked it to just use the location data that we have in our auto load instead. So that's what I did there. And you can see we're just referencing locations.list, which is the dictionary, and we're using the location name to get that key, and then we're just referencing all that data of that key. So yeah, that worked. That was pretty easy, thankfully. I think trade screen wasn't too bad either. So trade window. Okay, so lots of things. This one was a bit more involved, I think, because let's see, we had to get trade goods, location, and prices. Before we were using like location data.name, but now since I'm just passing in the name, I can just get that. And then anything in this code that needed to reference the location data, I had to, swap that out by getting, let me just do a control F for loc name. So, that's another one there. Here we go. So before I was, when I was emitting the signal, I was passing in the location data. Now I don't have to do that, so that's cool. And also same here when I was finalizing the trade. Before I was just passing in all of the location data back up, and that was not good. So made a few tweaks there. That was helpful. It wasn't too bad. I only crashed the game a few times making those changes. So nothing big there. Those weren't too big a deal. So we talked about those. Let's see. We talked about star systems. So I added the star system map. This was way harder than I thought it was going to be. So let's talk about this. Holy crap. Okay. So let's go up to other scenes, because that's where I added it for some stupid reason. It should be UI, but I added it under other scenes like an idiot. So let's go to map scene. Let's go to... Okay. So if we look up here, my node tree for this scene is I have the root node as a type canvas layer, and then I have a viewport container, and then I have a viewport inside of that viewport container, and then I have my zoom camera, the same camera that I use on my ship. I just added that to this scene and set it to be current. And so what's happening here is that when we load up this map, you can see I still have a few to-dos here already because it's super rough. I'm going to get into those in just a moment. But, so I have some variables here. Determine current system. I probably don't even need to use this now, actually, because since I moved that. Yeah, this isn't even being used anymore because I factored that out. It's now using star systems.current system, which we talked about earlier. So, yeah. Boom. Look at that. Catching bugs, not bugs, but leftover code that doesn't need to be there. So here we're doing something similar that we did in the star system mapper tool. So I have a packed scene of my map marker scene. And then I have a dictionary full of lines, which is what we use to keep track of lines so that we don't draw them twice. Because how I iterate through every system is I'm going through every system and then checking its neighbor systems and then drawing lines to it. Well, if I did that without determining if we already drew the line first, we could be duplicating lines. And again, if we're going to have potentially like 1,000 star systems and they could have many neighbors, you're going to have like many lines being duplicated. So you might have like 1,000 star systems and like maybe like 7,000 lines. Well, if you double that, now the game is drawing 1,400 line 2Ds when it doesn't need to. So I just store those in a dictionary. And again, using the same system that I was before, where the key I want to be system name dash system name that it's connected to, but I want it to be alphabetical. So that way I don't duplicate it. So if I'm trying to do Genesis to, you know, Harmony's Reach or whatever I call the other system, I think G comes before H, so it would always be the same. So when it comes time to do Harmony's Reach, and it's iterating through its neighbor systems, and it's trying to draw a line to Genesis, it's going to detect that, hey, that line's already there. I don't have to redraw it again. So I'm also loading in my camera, or not loading it in, but just getting the reference to it. That way I can use it. And then I also am getting a reference to our viewport, so I can add stuff to it. So in my ready function, again, which is called when the node enters the scene tree for the first time, I'm updating my camera position to match that of our current system. So I could just use cam here. I don't know why I'm doing that. Oh, wait, no. Yeah. Camera 2D, zoom camera. This isn't right. There we go. I must have moved that around. Weird. Look at that. More variables I declared that I didn't even use. Okay. So, setting the position to be, you know, what the current star system is. We're accessing star systems.map, which is my big ass dictionary of the star system map. And the key that we're using is star system's current system, and we're getting the position value. So we're just setting our camera to be centered on that position. Now, iterate through each star system and add it to the scene. So I'm doing a for loop. So for every key, so as you see, we're doing this keys function here. This returns a array of every key that is in that star system map. So every actual star system. And what we're doing is we are creating a map marker scene instance. We're instancing our scene, which you can see here is of type sprite. I'll get into what that scene looks like in just a second. We're setting the data for its tooltip. So we're setting it to be key. So we want the this is not its tooltip. This is it's a label. And we're setting it to so we can label the star system, so we know what system it is. We are updating its position, so we're setting it to be the position that is supposed to be for this star system, which again we got from our star system mapper tool. I'm also setting z-index so that it appears drawn above the line 2Ds. So that's why I'm setting z-index there. And then I'm adding it to our scene. So I'm adding it to the viewport here. So I'm adding all this stuff to this viewport. And we're going to get into viewports in just a second. That's a whole complicated mess, but fun. So we are connecting some signals. I had a bunch of other signals here that I didn't need. So I might add them in later, but for now I'm not using them at all. So I just commented those out. And the only signal I care about is if we click a star system. I'm also adding it to a group star systems, which this was something I was working on. I don't think this is even needed anymore. I might put it to do. Is this even needed anymore? There we go. So next I'm determining, hey, so we've added this star system to our scene. Are we discovered? If we're not discovered yet, we're going to hide ourselves. Now, once we do that, we're also iterating through and adding a line for every neighbor that the star system has. So we're running a loop inside of a loop. So that's already a pretty computational heavy task. So we're doing neighbor systems. So for every n is for neighbor. So for every neighbor, we're determining, hey, if one of our neighbor systems is discovered, then we should be visible. So if we are, if our neighbor system is discovered, which means that the player has been to it, which reminds me, I have to fix something in my warp to new system. I have to update this. Set this set selected system as being discovered. So star systems dot map, and we're gonna, and since at this point here, since we haven't updated our star system, our current system to be the selected one, we're going to use this one for now, or as of right now. And then we're going to do discovered equals true. There we go. So we are updating that. So I wanted to get that before I forgot about it. So let's go back to our map. So we're saying, hey, if this system is discovered, then we should be visible. So then we're setting our star system to be visible. Now, to prevent duplicates, this is basically a blurb I copied and pasted from my star system mapper tool. To prevent duplicates and also find lines we need to delete them, which I don't for this, but whatever. we need to create a string like sysname1-sysname2 with the system names being in alphabetical order. So how I do that here is I default our system name to being first. So I create this line name, which is just the key with a little string added to it. And yeah, so key plus the dash plus the neighbor system. However, if our neighbor comes first before our key, now again, if you didn't watch the last episode, Godot is really nice when comparing strings. If you just do less than, and it means that it comes first alphabetically, which is fantastic because it means I don't have to do something like convert it to ASCII characters and then, you know, determine if the character is higher up in this array. Then it was much easier to do it this way. Thank you, Godot. I love this engine. It's fantastic. So it looks like our neighbor system is first. So let's make it so. So we're updating line name to be neighbor dash current system. Now that we have our line name figured out, and sure we don't already have this drawn, so again, I'm using, anytime I add a line, I add it to my lines dictionary. I'm saying, hey, if lines has this key name, this line name, it already exists, so we don't have to do anything else. So actually, instead of doing return, I could probably do, I should probably do continue. So that way it continues on the next iteration. I think that was a bug that I didn't catch because I only have one neighbor system. So interesting. So that should continue on the iteration. So we'll say do nothing and continue iteration. So if we've gotten this far, the line does not exist yet. So we're going to create a line 2D and add it to the scene. So you can see we just have this value variable called link line, which is of type line 2D. Instancing that with the .new. We're adding it to our viewport. And then now we're going to define the points where this line should be drawn, as well as the width. I should put also a to-do. Determine line color as well. Because it defaults to like purple or like whatever it currently is. So we have link line width. I set to be 2. It defaults to 5, which is like super thick. I don't want a thick line, so I just slimmed it. 1 was like a little too small, so 2 was kind of perfect. So I just made it 2. Then we're defining the points that this link line needs to go to. So line 2D, so point A, point B. That's all we're doing. We're just defining by the positions. And then we're setting the Z index to equal 4, so it shows up below our actual node stuff, our circles. And then we're making sure that after we add it to our list of lines. And let's see. And then we're also determining, hey, should this line even be visible? We're going to default it to false, because for the majority of the game, you're probably not going to have a lot of the star system, the map discovered. So it's very probable it's going to be false. But if you have discovered the star system or you have discovered a neighbor, then we want link line to be visible. So we're setting that. So when the map loads, that's what it's doing. It's loading up. It's drawing all these different nodes, and it's connecting the line. It's making sure it doesn't duplicate lines. And if I had more star systems, it wouldn't show them until I discovered them, either a neighbor to them or them themselves. So yeah, that's what I got going on there. Now let's see what I got going on. So I have an input event. So when I hit M, so if I go back to main here, and I go back to my process function, so I have an action called show map, which I just have set to M. I'm instancing the map, adding it to the canvas layer. Actually, no, our map is a canvas layer, so I'm adding it to our scene. and I'm connecting the signals. Currently, the only signal I have connected is new destination. And then I'm pausing the game. So this makes it so that when I play the game here, let's see if I can get somebody. So let me just boost over here, right? So right here, this ship is like right here. If I pause the game, right, he should still be going up. But I can set my map to ignore the pause. So even though the game is paused, my map is still working. So when I click this Harmony's Reach, or if I just hit escape, because I don't have any UI right now, you can see it unpauses the game and we're right back where we were. So super handy. I like how it does that. In GameMaker, if you wanted to implement a pause and you hadn't done it from the start, you would have to go through like all of your step events for every object, and you would have to do like, is game pause, and you have to use like a global variable. Godot just has that built in, which is amazing. I love the fact that it does that. It saves so much trouble, and the fact that you can tell certain things to ignore being paused is even better. So I'm pausing the game, I'm displaying map, and if we hit escape, so is action pressed escape, we're going to unpause the game and delete ourselves. So I'm setting pause to be false, and then queuing myself to be freed from the tree. Now if my star system is clicked, so this is a connector function that I have. So for my map marker, I have a signal called clicked, and basically whenever I have these auto-generated functions from connecting from the node editor. So when you enter the mouse, it will display a tooltip for the map marker. And then here's me just, just setting up the tooltip data. So we're going to name the star system, what faction it belongs to, and then also we're adding in a bunch of locations. So we're just doing that. I think a lot of this was just copied and pasted like directly from my star system mapper tool, because it does the same thing basically. So we're setting the text, getting the viewport, and then we're adding the child to that. So yeah, this get viewport just adds what current viewport it's currently on and just adds it to it. So that's fantastic. Then we're offsetting the position of the tooltip just slightly. I have those offsets defined up here. So 20 pixels to the right and 10 pixels up is for the name offset. And then for the tooltip, it's going to be 25 to the right and then 10 down. So there's a little bit of a gap there. Now, on a input event, area 2D input event, we are detecting mouse click. So we're saying, hey, if this is not a mouse button event, do nothing. Just return early. If it was a mouse button, determine if it was the left button. If it wasn't left button, do nothing. If it was a left button, determine if it was a click. So we are determining if it was a click, which is emitting a signal that we clicked, and we're including the star system name that we actually clicked on. So that's what we got going on there. So star system name is just what's given to here. It says it should be set before adding it to the scene. So that's what I got going on there. So again, the map is super basic. I just threw a bunch of stuff on a viewport. Now, why did it take so long? Good question. I wish I knew. I still don't. So viewports, fun thing. Let's talk about viewports. And what I'm going to do is I'm going to move myself over so we can actually see some properties and stuff here, because boy, oh boy, this is fun. So first things first, viewports. So when you add a viewport, first of all, it defaults to 3D. So I had to go here and I had to set the rendering. I had to set the usage to be 2D. I also had to turn HDR off, or else it wouldn't even work, because again, HDR is only for 3D. So yeah, if I had this turned on, it just wasn't doing anything. So Once I figured that out, turn that off. Cool. Let's see here. Handle input locally. I think I turned that off. I don't know if that actually did anything or not. I guess we can test it. So if I save this and run it. No, let's hit the map. Okay. That didn't seem to matter. So that wasn't that defaults to on, which is fine. Next up, we got physics. Now, I don't use physics because I've been just using Node 2D, so I haven't been using like any kinematic body 2D or like anything like that. So I ignored it. Now, this object picking, if true, the objects rendered by viewport become subjects of mouse picking process. What this means is that if you don't have this turned on and you save it and you run it, new, let's hit the map. My scroll wheel works for my camera, but I can't mouse over it and I can't click it. It's like it wasn't registering the events. Now this led me down a nice big rabbit hole because apparently in a lot of versions of Godot 3, there was an issue that was popping up to where viewports weren't viewport containers weren't passing down input into their child viewports. So a lot of people had this this problem, and this was reported like with Godot 3.0, and then so yeah, 3.0.stable.official. So this was like when, you know, Godot 3 kind of first came out back in 2018, I guess, apparently. A lot of people were reporting it, and then it was reported as being fixed. The issue was closed a few times, and then it was marked as resolved, and then it would pop back up in later versions. They'd go back and they'd fix it again. Another version would come out, and it would still somehow be borked. So people were making workarounds. So the first workaround that some people made was that for the viewport container, you would just have the input event, and then you would just pass that input event into the unhandled input event of your viewport. And that was kind of working for some people. Some people wanted to just do position only, so they had a few different fixes, a lot of stuff like this. So I kept like digging into this and trying to make this work. But thankfully for me, the issue is resolved in Godot 3.4, which is what I'm using. Who knows what will happen when I eventually update to 4.0? Who knows? But this object picking was the source to all, well, not all of my problems, but a lot of my problems. So once you check that, which is not checked by default for some random reason, I don't know why, now it gets mouse events. So I can mouse over it, I can click on it, it does things, it works, it's fantastic, joy. Fantastic. The other thing that I had a really hard time with, and I still don't quite understand it, is when I was adding stuff to my viewport, so I was adding my star systems, my map markers would, you know, have their own labels, and they would add them as a child of themselves, which normally would have their position, you know, be the same as theirs, so I can just offset it slightly. But what's happening is if I comment this out and I just only do like add child label name. So if I just do this, I just add it to just myself. If I run this, where the hell are my labels? I can't see them. Why can't I see them? So it took me forever to figure that out. And I think I see like a super tiny thing right there. Do you see that? I think that's the actual labels. I think they're right there. Imperceptibly small. I just now noticed that. I didn't see that before. So I couldn't figure out where the hell my labels were going. I couldn't figure out why I couldn't mouse over stuff. I was just having a bad time with viewports, man. So what I had to do is, rather than adding it as a child of myself, I had to add it as a child of the damn viewport and then set the global position manually. Once I did that, it worked. And I still don't quite know why. So now you can see I've got my labels here where they're supposed to be, and everything's fine. But yeah, so that was fun. I didn't quite get why it wasn't working. Maybe it's because I was adding a control node as a child of a node 2D, which is not really good. Control nodes, I think, are, you know, derived from canvas layer or canvas items, which, you know, you should probably put as part of a viewport or as part of a canvas layer. Maybe that was what's going on. I don't know. But that, fighting with that took me hours of just trial and error, just trying different stuff, Googling it, asking ChatGPT desperately to figure it out for me, and they kept giving me all the wrong answers. So that was a lot of fun. That was a lot of what I did, was just ironing out those two things, like why my labels weren't appearing and why I couldn't interact with my damn star systems. So once I got that figured out, again, physics object picking down here, this is the very important part. So yeah, let me move myself back over here before I forget and just awkwardly talk with my head in front of everything. I probably already have done that, but whatever. So now if we go back to main, let's talk about what else we did. Again, this is a long one, man. I'm sorry, but I had a lot to do. So let's see. We add star system map. Big blockers are being able to see labels and detecting input. We already covered all that, so cool. And then finally, I added the ability to warp to another system. So let's talk about that. So if we go to our ship, let's go up toward the top here. So let's see. So to achieve that, I added another state constant for hyperspace. So then I also add this variable called hyperspace phase. So let's talk about what that does. So if we go down here to AI state hyperspace, so this is what the AI does when it wants to hyperspace. This is also what the player does when it hits the hyperspace button. It cedes control over to the AI so that it can do things for you, like slow you down, rotate you where you're supposed to go, and then generate, like, you know, boost you out. I don't want somebody trying to move around and shoot while they're trying to boost out of the system, because it would look all wonky and it wouldn't work right. So I take control away from the player. They're locked into that animation for the full duration until they boost out. And yeah. So here we execute this in phases. So I made a comment on what hyperspace phase does. So hyperspace phase is just an integer. It's a whole number. So it can't be a decimal. It's not a float. So 0 is the setup phase. Phase 1 is the position phase, where you slow down and face the direction that you need to go. 2 is the wind up phase, where like your boost is charging. And then 3 is the hyperspace phase, where you just blast off, baby. And then phase 4 is completion. So determines what you do at the end of that, whether you load into a new star system because you're the player, or if this ship is an AI, it just destroys itself, because who cares about tracking another AI ship to a different location that's not rendered. So yeah, fun stuff. So setup phase. So here we go. Hyperspace 1 or hyperspace phase 0 setup. We're determining variables. So are we the player? If we are, then our hyperspace angle is going to equal star systems get direction to neighbor system, star systems selected system. So we're just wanting to face the angle of our selected system. So I showed that off earlier, how it points in that direction. That's how I did that. If not, then what's going to happen for the AI is that they're going to use the same function, but we're not specifying a neighbor system. It's going to pick a random neighbor system. Now, since I only have one neighbor system for this current system, it's only going to pick the one. But if I have a bunch of them, you're going to see ships like warping out to all sorts of different systems. So that's what we got going there. So our setup is set. So I'm advancing hyperspace phase. So now we're actually in phase 1, which is our position phase. So what we're doing here is we're slowing down. So decelerate is true, accelerate is false. We're facing our direction, which is where I'm leveraging that rotate ship function I talked about earlier. Determining if we are slowed down enough and facing the right direction. Now, this is kind of a problem. Now, when you're comparing floats, it gets problematic because, again, a float can have a whole bunch of decimal places. And depending on how the math is done, you know, you might think that your velocity, your speed of your ship might be 0, but it might be 0.000000000 repeating 1, you know, and that doesn't equal 0, believe it or not. So what I have to do is I have to stepify it, which locks it at only 2 decimal points, and then 0.00 is equal to 0. So those comparisons work. And I'm also doing that here for when I'm determining if, you know, our rotation of our ship is equal to our hyperspace angle. So we don't want to actually blast off until our ship is slowed down at a halt, and also it's facing in the direction it needs to go. So once we're there, we're good. Advance to the next phase. So I'm advancing to the next phase. I'm also starting to play the build-up sound, which is, what the heck? Oh, my phone went off. I'm playing the build-up sound, and then I'm just outputting stuff to the console for debug purposes. I should probably get rid of those, but whatever. I'll do it eventually. Now we advance to the wind-up phase. So this is where I have a hyperspace timer. I could use a timer node, but I feel like it's more hassle to use those. I just set a timer for like the duration I want in seconds, and then I just subtract delta, which is the time since the process ran last, from that, and that allows me to keep perfect time. So I'm just managing my own timer, and then once the timer is less than or equal to 0, I'm advancing to the next phase. So I'm resetting my timer to be 2 seconds because we're going to reuse it. So it takes 3 seconds for the wind-up phase, and then once you go, it takes 2 seconds of actual boosting to hit the next system. I just did those just for some fun numbers, so it looks cool. I could probably tweak those around. I could have gotten rid of those entirely, to be honest, but I think it adds a lot to the game as far as like immersiveness, to make it feel like you're actually going through the, you know, you're boosting. So I'm resetting my timer, and then I am setting hyperspace phase to the next phase. Then we're also playing a sound. So if we are the player, we don't want to use positional audio, because if we use positional audio, if we, I'm using a, yeah. So if we use the enter hyperspace sound and you're doing positional audio, since you're boosting away so fast, the audio will just fade away super quick before it's even done playing the sound. So you effectively wouldn't even hear it. So I just use play sound, which just, doesn't take position into account. So, but if we are a AI controlled, we're not a player ship, then just use the positional sound from my audio manager, and we're just playing the sound at our global position. So that's all we're doing there. Next, we also want to loop a sound. So I'm not going to use the audio manager for this because I want the sound to loop, and then I also want the sound to stop when we're no longer, you know, boosting. We're no longer hyperspacing. We're no longer warping. So I'm just making a audio stream player 2D, a positional sound player. I'm just adding it to myself so that my ship, whether when it's done, it will stop playing when the ship is deleted. So I don't have to manage that sound separately through the audio manager. I just set it on my ship, and then it gets taken care of when the ship is cleaned up by main scene. So that's why I did that there. So I'm declaring a new sound player. I'm setting the properties. So stream, I'm setting the sound file to use. So I have a loop hyperspace. Setting the playing to be true. Now, the option to set it to loop is actually on the import settings of the file itself. So if I go here to my sounds, and then go here to loop hyperspace, and I go up to import here, you can see loop is set to checked. So I had to go in here and check that, and then hit re-import, and then it was able to loop. So that's what I did there. Now we're in the hyperspacing phase. So we're in phase 3. So we're decrementing our timer. So we only want to be hyperspacing for like 2 seconds. So we are going mega speed. So here I'm manually overriding our velocity vector, which our ship uses. And yeah, I think I'm yeah. So I'm setting it to go super fast. And what I'm doing is I'm just making a normalized vector, a new one. So its direction is 0 and its magnitude is 1. And I'm rotating it to be the hyperspace angle. And then I'm multiplying its magnitude by 6,000 multiplied by delta. So I want it to go like 6,000 units per second. So that's what it's doing. It's going to travel 6,000 pixels in 1 second. And then I'm emitting a signal that our speed changed so that my UI also can keep track of that speed change. But yeah, that's what we got going. So, all right, next we're checking, hey, are we done warping? If we are, I'm just outputting to the debug log here, printing it. Now, if we are the player, we want to play the sound of exiting hyperspace if we are the player. So what we're doing is we're doing audio manager, play sound. So what this does is, since I'm using the audio manager, playing the sound will persist after the scene is cleared and my ship is deleted and recreated in the new scene. So that's the benefit of the audio manager. I'm glad I went through the effort of making that. And then we're advancing to the next phase if we are the player. If we're not the player, we're just queuing ourselves for deletion. We're just gonna free ourselves from the tree, destroy ourselves, because there's nothing else that needs to happen for the AI ships. Now, once we get to phase 4 here, completion, we are the player, or else we wouldn't have gotten this far. We're gonna emit a signal, which is connected to the main node. Hyperspace complete. And then we're advancing the phase again, just in case this ends up running again before the signal is actually handled, which I don't think it will do, but I wasn't sure, and I just wanted to just be safe. I didn't want to like implement a signal twice or multiple times and have main constantly wiping the scene and stuff like that. So that's what we're doing there. That's how we were able to do hyperspace. And then we also add some particles too. So if you notice when we're boosting, I added these particles. So if we go here to particles and hyperspace, go to 2D, you can see I have this little cheesy particle effect here playing of these little stars just kind of going by. I need to change the, make this a little bigger, I think. And we'll go -4,000. There we go. So we got a bigger box. That should fit. And just for funsies, we'll do 350. There we go. We got more. So as we are doing hyperspace, new. Let me go cover that up. So let me hit our thing. Keep boosting so we go super fast. N, and then once we start boosting, it'll play that particle effect. Yeah, see, woo, there we go, we're boosting. So, kind of funny, kind of works. I have it so big so that sometimes if you zoom out your camera all the way, it was only showing like a few of them. So it kind of looked weird. So that's why I did that. But yeah, that's basically it. Only almost 2 hours of me just talking. But yeah. So yeah. Whew, I am so glad this works, because now it's going to open up my game so much once I get all these stuff finalized, because then you'll start actually being able to go explore star systems, and I can start defining locations and, you know, different events. I can start working on the events system, which I'm going to have to do. Also start working on the quest and dialogue system and stuff like that. So it's coming along. This was a lot harder than I thought it was going to be, but I think now I got an okay grasp on it. It's kind of a fun crash course into using viewports, and yeah, I got a lot of things to do still. So these are just miscellaneous things I keep documenting. So I have to implement a cooldown on boost to prevent exploitation. I got to research and fix the following bugs. So clear scene does not clear projectiles or selected target indicators. I think I've got that worked out. That should be an easy fix when I get to it. This one I don't know how to fix. Sometimes while playing, it seems like my ship's velocity just gets reset to 0, and I don't know why. And it makes me sad. So yeah. So parallax background is not tiling correctly for the foreground layer. So I don't know if you can see that very well. But if I get in my ship here and I go over here, you can kind of see it here. Let me go in my other scenes, parallax background. So for parallax layer 2, so for this, where do I set the... Here we go, modulate. So if I crank this up even more, you'll be able to see a lot better. So if I go here, so now everything kind of looks blue. You can see like more stars and stuff. If I boost over here with my camera zoomed out, you can see it doesn't go all the way until I get like right over here, and then it goes over. So I have to fix that still. Still working on that. I also want to make the left panel UI appear when hovering over a ship, not just clicking it. I think that would be really cool to be able to mouse over stuff, especially if you have the option turned on to control your mouse, to control your ship's rotation with the mouse. Could make it a lot easier to see relevant details about the ship you're actually shooting at, which could be handy. I have to finish the rest of the right panel UI. I don't know what needs to be done on that. I gotta like figure out all the other stuff to put on there, but yeah. I still have to refactor some polling code to use signals. I think my left panel UI is constantly checking and updating labels and stuff, so I have to fix that. Decide how I want to handle spawning ships in various systems. I talked about that a little bit. Tab targeting. I also want to be able to hit tab and like target through, you know, ships that are near you, or like in a cone. If you've ever played World of Warcraft, tab targeting in that game is awesome. If you've ever played Final Fantasy XIV, tab targeting in that game is trash. It's the worst I've ever seen. So I don't want to do what they're doing. I want to do what WoW does. So I'm going to have to look into that and see how they handle it. But I got an idea on how they do it. Next, I want to figure out a global options system. So, you know, I can hit escape and bring up like a little menu or something like that, and then you can go change options about things that you want to do to make it. Maybe I'm going to add some like game difficulty to it. So with that, I'll be able to scale like shields and health and damage of like enemy ships and also allies. So if you want an easier playing experience, you can play on easy mode, which will, you know, make friendly ships have make them beefier, and then it'll make enemy ships a little scrawnier. So stuff like that. But those are the to-dos I've got. I still have to figure out brainstorm events and events. story and dialogue systems. So I still gotta do that. But that's where I'm at. I am so glad this is done. I'm so glad this works, man. This took so long to get done, and I'm just glad it works. Come on, get farther out. I also have to add some indicator to let you know that you're far enough out. So if I zoom out for this, let me see if this effect works now. There we go. So, yeah. So there we go. Look at that. We are now in a new system. So, I'm so glad that works. Anyway, if you made it through this, you must be bored. Because, wow. Anyway, thank you all so much for watching. I appreciate it. And I'll see you in the next episode, which will probably be... I would say it's probably going to be at least like 2 weeks before I have any more relevant progress to show on this game. Because work's been really busy, and I've got a lot of other content that I want to make in addition to working on my game. And, you know, I think the big things here, like brainstorm the event, story, and dialogue systems, that's going to take a bit of work. So, anyway, thank you so much for watching. Again, I appreciate it, and I'll see you in the next episode.